Hi. Hello, everyone. Ladies and gentlemen, my name is Pan from Alibaba DAMO Academy. And today I'm very delighted to be here to illustrate some of our work on large-scale image search and recognition. So the outline of my presentation is given as follows, 3 parts. First of all, I'll briefly introduce about us. And then I will illustrate the technologies related to large-scale image search and recognition. And the third part is how we utilize the technologies into real business applications within Alibaba and also on Alibaba Cloud. So first of all, about us. So Alibaba DAMO Academy was founded in the year of 2017. DAMO stands for Discovery, Adventure, Momentum, and Outlook. So the purpose of Alibaba DAMO Academy is to try to do research for solving problems with profit and for fun. So at DAMO, we have been doing research for the 5 areas, including machine intelligence, data computing, robotics, financial technologies, and X laboratories. The machine intelligence research sector is where I come from. It consists of 5 research labs. So for the speech lab, we are doing research related to speech recognition and speech synthesis. And for vision lab, the topics is related to like image understanding and video understanding as well as 3D vision. And also we have a lab called Language Technology Lab where we have been doing research related to machine translation as well as semantic computation. And also the topics of large-scale machine learning and optimization are covered in the research lab of decision intelligence. And also we have a research lab called City Brain where we trying to doing research related to the complex problems in the city. So as we all know that at Alibaba we have a wide range of coverage of business from e-commerce to financial services, to local services, digital entertainment, as well as logistics. And we have obtained a huge amount of data through those real business scenarios. Based on the data and combined with our computing technologies and the AI technologies supported by DAMO Academy, we are continuously to improve the experience of our users. We are continuously trying to shape the new business opportunities. So this is our first part. And the second part, I will illustrate what is image search and recognition, the motivation, the technology challenges, as well as our technology innovations. So the motivation of image search and recognition could be summarized by using one simple sentence. That is, a picture is worth 1,000 words. Let's see an example. If someone sees a red handbag as shown, the one sitting in the middle of the image, and we want to search on the web. And someone would recommend to use text search. Then we have to type in the text, something like red leather top handle handbag. And the text search engine will return the results. And in general, the result is not exact what we are looking for. So we are developing a powerful image search and recognition engine that could give us the identical or very similar results just based on the understanding of the current image. So although we just say that it might be very promising of image search and recognition engine it may have many technology challenges. The first one is for same object or same product, the appearance is the difference of appearance is very large in the offline world and online world. And we can see that the cases of the sweater and the case of the shoes, we can see that the image looks quite different, even it is the same kind of product. So the second challenge is that because the number of products are so huge, and we have to do very fine grid classification. Because on the image we can see there are 4 watches, and they belong to a total different brand. So they are totally different products, but they look very similar. So it's also very challenging for the system or the machines to really understand how to differentiate them. So the third challenge is the lack of training data, because these days we are using machine learning technologies, for example, deep learning models to train the neural network. However, it requires a huge number of labeled data. So, so this is another challenge. It is very difficult or even very expensive to try to allocate those training data. So based on the challenges, I will first talk about our pipeline of image search and recognition, and then move to the technology innovations. So in general, there are two processes of image search system. One is called the offline process, and the other is called online process. For the offline process is that we process every single images in the data set. So first of all, we do object detection. That is because we are only interested in the object or product within the image. So we do object detection, and then we do feature extraction. And at this time, each object within each image is represented as a feature vector. And then we develop the index engine to index the data. And later I will give more details about the indexing algorithm. And then for the online process, for each query image of the users, we do 3 things. One is category prediction, and again, object detection and feature extraction. And then we do the search in vector space among the index engine. And in the end, our service can return the top K results based on the similarity. So this is a general pipeline of image search. And then we can see that this page illustrates a general pipeline of image recognition. For a given query image, we can train a classifier, for example, a deep learning neural network, and we can classify which category of the image belongs to. So for example, for the given case, it is Coca-Cola 3 milliliter bottle. So this category approach is called model-based. So there is another way of doing the task that is called search-based. That is, we generate an index engine of the training data. So for query image comes, we first search among the database, and then we can get the top K results, and then by using some voting mechanism, for example, weighted KNN, we can also classify what category of the query image is. So sometimes the two approaches, model-based approach and search-based approach, they could be combined together to better improve the performance. So next, we'll talk about the technology innovations. Through the years, we have done a lot of technology innovations. So today I will share with you the top 3 most important technology innovations. The first one is robust learning with feedbacks. The second one is large-scale training. And the third one is large-scale indexing and retrieval. For the first one, so the first one is how to train the network to get a very robust feature representation without additional annotation of the data, because we get the training data from the feedback of our customers. Because in our scenario of image search, the users will see the returned results and they will click what they like. So the clicked image is considered as a positive sample related to the query image. And the long-clicked image is, could be considered as a negative sample of the query image. So in this way, we can form huge amount of triplets. And then we set up a deep learning neural network that could utilize the triplets based on the user's feedbacks to train a robust feature representation. And the loss of the CN network is ranking loss, depending on the distance between the query and the positive sample and the distance of query and negative sample. So the key of this method is that we have to dynamically to construct the triplet. So this is the way we can get training data without additional particular labeling from humans. So actually the behavior or feedback of our customers can make the system very intelligent. So there is a furthermore, we can generate item-to-item metrics based on the click of the users, and then we can do graph embedding to get feature representation of each image, and then we can do clustering algorithm in the feature space, and in this way, the centroid of each cluster is considered as a label. We call it virtual ID, and then we can get training data. So there is no additional labeling. So simply all the data is from the humans' feedbacks. So the second technology innovation is called large-scale training, because we may have heard image classification task of how to classify among like 1,000 objects, 10,000 objects. However, in real applications, because the category or the number of products are so huge, we have to do huge amount of classification tasks. For example, image classification over 1 million. And therefore, we develop a hybrid parallelization system to handle the huge amount of training. For example, we use data parallelization to parallelize the data. And we also use model parallelization to parallelize the softmax layer, because usually for classification task, we use softmax layer network structures. And then based on the general framework, we do technology innovations such as pipeline optimization. So by using pipeline optimization, we can speed up the iteration time by 25%. And we also develop a very novel convergence algorithm called fast continuous decay, which outperforms the conventional method by more than 2 times. So this, the third technology innovation is called large-scale indexing and retrieval based on the based on the vector representation. Because in the deep learning world, and each object or each image is represented as feature vectors. And therefore, the image search process is converted into vector search. So we come up with binary fast quantization method, which can handle huge amount of data, up to 10 or 100 billions of data. So the online speed is also very fast. It can return the top K results in milliseconds with near lossless recall. We can see this is the structure of the engine process. It is divided into like columns and rows. The columns is the distributed coverage of the index data, and the rows corresponds to the queries. And when the query comes, so each column machine first finds the top K results, and the top K of each column machine is merged together, and in the end, the final top K result is returned. So just now I'm talking about the technologies and technology innovations, and the third part is related to real applications within Alibaba and on Alibaba Cloud. So in Taobao AMP, so Taobao is Alibaba's online marketplace. So on the first page, we can see there is an image icon. So the users can click the image, the camera icon. The camera is on, and the users can capture any product they are looking for on the marketplace. And each day, we have over 20 million active users of such service. And today we have indexed more than 400 million products with more than 3 billion images. And also we have built an internal image search pipeline and framework and platform that can support the business within Alibaba. So far the image search solutions is deported into the following 6 apps of Alibaba Group, including Taobao, Tmall, AliExpress, Lazada, and Alibaba Domestic and Alibaba International. So the service cover almost all the products we have, so ranging from clothing, toys, furniture, accessories, cosmetics, etc. So the following are several sample images of our service. So the red bounding box is the automatic detection results of our algorithm. And so because in our application, so the user simply need to capture one image without additional operations. The algorithm will identify the product automatically and then return the similar or identical results as shown in the right figures. So we can see the results of shoes, drawings, furniture, and decoration toys. And also on Alibaba Cloud, we have launched the image search service in February of 2018. So we are the first major cloud companies which launch image search service on the public cloud. So in order to provide better service to our customers around the globe, so we deploy the image search solutions into the 5 data centers of Alibaba Cloud, including China Mainland, China Hong Kong, and Japan, Singapore, and Germany. So the following is a user case of the iconic company, which is the Australia as New Zealand's leading online fashion and sports retailer. They use the image search service provided by Alibaba Cloud and form a product called Snap to Shop, so which allows the customers of the iconic company can also snap to shop by using their own app. So some of you might ask if the solution only works for e-commerce. The answer is no. So this is another case of image search service used in the textile industry. So where we can do like fabric search. So the application scenario is as follows. So when the sales staff visit the customers at the customer's office, they can simply take a picture and to find if in stock they have the same or identical fabric. And also like for the production staff, and also they can very easily link a particular fabric with the stock ID and manufacturing materials and formula, etc. And also, we have extended our object recognition capabilities of over 1 million entities to the application on mobile Taobao. So far, we can not only just do image search, but also do image recognition of the following categories. We can see here we have a demo, which shows that so this is product, and this is barcode. So cars, flowers, pet, and some like marketing of AR or game effect. So we just noticed that we actually don't need to press the capturing button. We simply like just moving the camera in the preview mode, and the system can automatically doing object recognition, also combined with the image search. So also we have, at Alibaba, we have application called Xianyu, which is the largest domestic online marketplace for second-hand products in China. So on each day, there are over 2.5 million products published. So in this particular applications, the image recognition technologies are widely used to help the users to publish a product. For example, we predict the category, and we also predict the user-defined tags, and we even could do like price estimations. And also we have a demo here. We can see that the user wants to publish a product, and then our system recommend a lot of tags. So all of them are recommended by using AI technologies. And then like the user can type in the text information, and then we do automatic like price estimation, because the suggested price is 28, so the user choose 48, and the user choose 45. So and very quickly, a second-hand product is published on the platform. So and also by collaborating with LST, which is also belongs to Alibaba, is called Online Distribution Platform, and we have launched a product called Product Recognition and Management for Retails, where we're trying to use AI technologies to digitize the whole offline shelf. We simply take a picture of the shelf, and then we can identify which particular SKU and the number of SKUs in the display facing. And furthermore, we can do the analysis for the particular brand. For example, the right figure gives the example for the brand of lace. The shelf share is 27%. So we also do like face counting of in the display facing of a particular SKUs. So by using this service, the manufacturers and the distributors of particular product is very appreciate these functions, that they could know the information about their competitors and how much percent of shelf is consist by their brand. So before I finish, I would also like to share with you about our thoughts about the future of image search and recognition. So in general, we think there are two trends. One is multimodality, and currently we only use the image data. And we believe that in the future we can use more input, for example, text, voice, or even videos. By combining all the data, we believe it could improve the experience of our users. And another trend is more interactions, because currently the product of image search and recognition is some kind of lack of human interactions. So therefore, we believe that in the future, we want to incorporate more like interactions of our users into the image search and recognition system. And this concludes my presentation today, and thank you very much.